Hello and welcome back to another episode of Math with Zone. Today we're going to be doing the Problem Lab example candidate response. We did this lab earlier in the year most likely, where you have two weights and then you just let one go and it kind of wraps around. And it will always ask you to do something simple in the very first part, which is, in this case, measure the value for A. Okay? And in this case, it said 2 points. If it says 2 points, you're not supposed to do 3 trials. You should be doing 5 trials because every other mark scheme says 3 is fine and the other one says 5 is fine. So you should be doing 5 trials here. So you should have another 46.5 and then another 44.3, something like that. Okay? And then that would be how you get your average value. I recommend doing a table for this. And you do trial 1, trial 2, trial 3, trial 4, trial 5, average. Okay? You just have to show it on the one that says 2 points when you wouldn't necessarily expect it. I expect it to be a timing situation, not a measuring situation, but you never know when that 1-2 point question is going to show up on the problem lab. Here it showed up on the measuring of the length. All right? Afterwards, you're going to probably be expected to find your percent uncertainty. When you do your percent uncertainty, if you've done 5 trials, they did this as well, you just can't see it. It's 1/2 max minus min, divide by the average, and then multiply by 100. That is exactly what they did. If you look here, they got 48.5 to 47.5. Well, the difference between max minus min is 1, divided by 2 is 0.5. So they did do that. It's just a little weird. I'll write it for you. 1/2, 48.5 minus 47.5 divided by 48.1 times 100 if we go with their average value. And then you get 1.04, okay? Afterwards, you're going to have to do some funky math. Funky math just means do what they say, okay? Just do whatever they say. Don't worry about what it is. And then they'll ask you to repeat the experiment and change one thing. So in this case, they changed the angle to 45 degrees. We have no idea what yours is going to be, but you repeat everything again where you have to measure the height and the cosine squared or whatever they have you do again, but in this case, you're not expected to represent the 5 trials. I recommend, even though you're not expected to show it, to do 3 trials here. 3 trials. All right? The reason why I say 3 is because the first one, you have no clue if it's correct. The second one, it confirms if the first one is correct. And then the third one, it would tell you if, in fact, you do know if, like, let's say the second one was way too big and the first one was way too small. The third one might tell you if it should have been closer to the first or the second. So my recommendation is 3 if you have time. Afterwards, they're going to ask you to find the 2 values for K, which I don't have that paper. Where is it at? Sad. They're going to ask you to find your 2 values for K. And those 2 values for K are using the values that they, like using an equation that they tell you. So in that case, I don't know why it didn't print. You would have to find 2 values for K. And after you find those 2 values for K, they'll ask you what is the percent uncertainty for K. The theory suggests that it's supposed to be 20%. So you find K value number 1, you find K value number 2. Both of those are going to be your K values. And then you would subtract them and divide by the average and multiply by 100. No 1/2. And if this number is greater than the value they tell you, 20%, then it's no. My value does not support that. If it is less than that value, then it's yes, my values do support that. Okay? That's all you have to do for that one. Now, when you're due find your values for K, let's say you get K is equal to apparently 0.444 and 0.260. Why did they choose to have 3 sig fig values here for the 2 values for K? Well, it would be based on the raw data for theta and A and blah, 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 and the other one would be H. That is why we chose 3 sig fig values. So when you're justifying your sig figs, you're going to have potentially 3 because odds are you're going to be measuring something with a ruler, and the reason that you chose 3 sig figs most of the time is because that is from the raw data for theta, A, and H. All right? The last thing you're going to be expected to do is say, what are the things wrong and what are the things that you can do to improve it? All right? These are very, very brief answers, but they do a decent job of coming up with like things that would actually make sense. Always, 2 readings are not enough to make valid conclusion. That is 100%. You need both valid conclusion, 2 readings, not enough to get the point. Solution, take multiple readings and plot a graph. You need plot a graph, you need take multiple readings, or do more readings and plot a graph, or do more trials and plot a graph. You need both of those to get the 1 point. If you have to measure anything with an angle, it's difficult to measure, okay? Because things are moving, it's difficult to get things parallel, it's difficult to actually just see it, and then you could either clamp the protractor, you could extend the angle with a thin string, or measure height and length and use trig. Okay, all of which would be possible depending on the scenario. All right. Another thing that is always going to maybe be there is there's going to be something that's just moving around or hitting each other. Like when we were doing the bowl lab, the bowls were hitting the sides of the thing. You could either use a longer rod, or you could use a bigger bowl, or you could use anything to where they don't run into each other. Okay? Then, if it's difficult to make sure that something's horizontal, or if it's difficult to measure a width of something, or if it's difficult to measure anything, then you could either try and make the instrument more precise. You could try and use calipers, but that's highly unlikely. You could use a spirit level to make sure something is actually horizontal. If it's difficult to time, if we wanted it to be difficult to time exact period, then you could, if it's difficult to time the exact period, use a camera with a time stamp visible. Or you could use slow motion frame by frame reference. Okay? That's going to do it for this one. Until next time, my friends, stay positive, and I will see y'all later. Bye.